My name is Christopher McQueen. This presentation covers my CEN 5035 semester project, the Customer Service Request Portal, developed under the CTN Development Group name. The portal gives customers a structured way to report service issues and gives internal staff one place to review, track, and update those requests. I will briefly review the requirements, design, and testing documents, then demonstrate the working prototype. The first document is the Software Requirements Specification, prepared using IEEE Standard 830-1998. The project addresses a practical problem for a telecommunications or managed services company. Service issues often arrive by phone or email, which can leave information incomplete or spread across different channels. The portal provides a simple online intake and tracking process without replacing the phone process for emergencies. The SRS defines 3 user levels. Customers can submit requests without an account. Staff members can search and manage requests, update statuses, and add internal notes. Administrators can also manage internal users and predefine request types. The document contains 36 functional and 28 non-functional requirements. The core workflow validates the customer's information, creates a persistent record, assigns a unique CSR number, sets the initial status to new, and displays a confirmation. The non-functional requirements cover performance, security, usability, accessibility, reliability, and maintainability. The initial scope excludes payment processing, live chat, automated dispatch, customer registration, file uploads, and full integration with an outside ticketing platform. The software design document translates those requirements from what the system must do into how it will be organized. It follows IEEE Standard 1016-1998, reaffirmed in 2009. The production design uses a Python and Flask backend organized as a layered modular monolith. Presentation, application services, data access, and external services remain separate enough to maintain and test, while the project stays manageable to deploy. The intended production environment uses Supabase PostgreSQL, Supabase authentication, Render, or a compatible WSGI host, and HTTPS. The first diagram defines the system boundary and the external users and services. The second shows the layered component architecture. The remaining diagrams cover the domain and service classes, database relationships, customer submission sequence, and internal request management sequence. Together, these views show how a browser request passes through validation and business rules into persistent storage. They also show how authentication protects staff features and how status changes and internal notes are preserved as historical records. The final document in the is the software test document, prepared using IEEE Standard 829-1998. The plan covered customer intake, authentication, the dashboard and request management workflow, administration and security, performance, and persistence. 40 automated test cases were planned and ultimately passed. The first complete run produced 39 passes and 1 test data incident. A persistence test used a request type identifier from the wrong isolated test database. The application correctly rejected the invalid identifier, so this was a fixture problem rather than a product defect. After the fixture was corrected, the full regression suite passed all 40 cases in 10.576 seconds. The traceability matrix maps all 36 functional and 28 non-functional requirements. Some production-level work remains, including live TLS, independent usability and accessibility testing, broader browser and device testing, and concurrent load testing. For that reason, the prototype received a conditional pass as a course prototype, not production readiness approval. I will now demonstrate the working local prototype. This public form uses plain language labels, clearly marked required fields, and an emergency notice directing urgent issues to the company's phone process. I am going to enter sample information, but I'm going to intentionally enter an invalid email address. When I submit the form, the server rejects the invalid value and gives a field-specific text correction. The error is not communicated through color alone. After I correct the email, the request is accepted and stored. The confirmation page displays a unique CSR number, and the new record begins with a status of new. I will now sign in as an administrator. The dashboard is protected, so request information is unavailable without an authenticated internal user session. The dashboard displays the request number, customer or company, request type, status, and submission date. It also supports searching by request number or customer name and filtering by status. Searching for Coastal locates the request I just submitted. This shows that the public customer workflow and the internal staff workflow use the same persistent data. The detail page displays the original customer information and service description. I will change the status from new to in progress. When the update is saved, the current status changes, and the system also creates a separate history record containing the previous status, new status, user, and timestamp. Internal notes are added as new records instead of replacing earlier information. The note records its author and timestamp and remains attached to the request as its status changes. Together, the status history and preserved notes provide a basic audit trail for the service process. The users page lets an administrator create staff or administrator accounts and review whether each account is active. Regular staff accounts do not receive these administrative functions. The request types page stores the choices used on the public form. Because those choices are managed as data rather than hard-coded into the form, the company can change its service categories without rewriting the main submission workflow. This demonstration uses SQLite, local password authentication, the Flask development server, and project-specific CSS. Those are documented testing substitutes for the production Supabase, PostgreSQL, Render, and HTTPS design. The routes, roles, validation rules, statuses, and data relationships remain aligned with the SRS and SDD. In summary, the SRS defined what the customer service request portal must do. The SDD defined how it should be organized, and the STD verified the implemented workflows against those requirements. The prototype demonstrates customer submission, validation, confirmation, protected staff access, request tracking, internal notes, status history, and basic administration. The next step would be production deployment and the additional external testing documented in the test report. Thank you.